case. All right, so there's our picture. All right, so our given is that AEB this is the bottom there. So AEB is going to be congruent to DEC. And we want to prove that angle AEC is congruent to BED. And you guys actually, I think, did one kind of sort of like this in your journal yesterday. Should look a little bit familiar. Okay, so let's mark up the picture. Even if we're doing a flow proof, it's a good place to start. So we're given AEB. This guy is congruent to DEC. That guy. Okay, they don't look like it in the picture, but I marked it that way, so it's true. Okay, so the beginning of our flow proof, just like the beginning of a two-column proof, start with the given. Put that in a bubble. So just this given information, what do we know? If angle AEB is congruent to angle DEC, what else can we say? If we know two angles are congruent, what does that tell us about the two angles? Gabby? Yeah, that their measurements are equal. Okay? So the measure of angle AEB is equal to the measure of angle DEC. Okay, and how do we know that? How can we switch from congruent to equal? Yeah. Definition of congruent. Yep. Okay. Line of logic right now kind of stops, right? Just focusing in on this fact, there's nothing more that we can really get from there. But if we go to the picture, there are lots of other things we can get from the picture. Okay? So we're going to start another line of logic from what we see in the picture. Okay? Think about what we're trying to prove. We're trying to prove that AEC and BED are congruent. AEC and BED. Do you see how both of those two angles are made up of two little angles inside of them? So what do you suppose we're going to do next then? Not yet. We're going to get there, though, eventually. Yeah? Mm-hmm. Right. We're going to add those angles together to equal the bigger ones. Okay. So the measure of AEB plus the measure of angle BEC equals the measure of angle AEC. these guys up here. Okay, so this one plus this one equals AEC. That's what I just did there. Okay, and we can repeat that for the other one, right? For BED, BED is made up of 2 as well. So it's all justification, doing all the same thing. So I can include this all as one big step. So then I also have the measure of angle, where are we at? CED. Or I guess I should do DEC technically, because that's how I wrote it up here. So DEC plus the measure of angle BEC equals the measure of angle BED. So this is all doing the same thing. So what allows me to do that, to add angles together? Yes? Nope. Yes? Angle addition postulate. Yeah, exactly. The name kind of gives it away, right? Yeah. But you got to remember it, though. That's the. If you can remember, oh yeah, there's this angle addition postulate. Oh yeah, I'm adding angles. That probably would make sense.
I thought of that because the
Okay. Take a look at this. AEB equals DEC. Now look at this. What do you notice? What could we do? Yeah. Yeah. We can do a substitution, right? Because AEB and DEC are in there, right? We used them. So I can replace one with the other. And honestly, it doesn't really matter which way you go with it, but you can replace one with the other. So I'm going to make my AEB turn into a DEC, okay? So this top equation, measure of angle DEC plus measure of angle BEC equals the measure of angle AEC. Okay, and then I still got this second one that's still the same. Measure of angle DEC plus measure of angle BEC equals measure of BED. Now, flow proof is concerned, I used both of these two things together, right? So this guy now flows down to this part now. Okay, I use those two together to get to this. And what would be the reason? What's the justification there? Somebody had already said it. I want someone else who hasn't spoken yet. Because you have spoken. So what did we just do? After that. Angle addition postulate was here. Correct. Substitution, right? We put it in there. Okay. Anybody see what we can do now? Put them together, right? They're both equal to the same thing. DEC plus BEC. So if those are both the same, then AEC and BED should be the same, right? So I'm kind of running out of space here, so I'm going to come back this way. And we can say the measure of angle AEC is equal to the measure of angle BED. And why is that? Yeah. You could say substitution or not yet. We're getting there. That's the next one. What's that property that says if A is equal to B and B is equal to C, then A is equal to C? Starts the transitive, yes. But if you said substitution, I'd accept it too. Because technically you are doing that. Okay, so my proof is kind of flowing backwards now, but it still works. Just follow the arrows. So now, because of AEC, EEC equals the measure of BED. Look what I'm actually trying to prove, though. I'm trying to be congruent. Well, doesn't that actually lead to that, though, right? If the measurements are equal, then the angles themselves are actually congruent. So I'm done. I can go one more step. Angle AEC is congruent to angle BED. And what's the reason? Abby? Definition of congruent. Yep. You sure did. It's okay. All right. And that's it. There's my flow proof of that one. Okay? Now, in your homework, you're going to have a lot more of the fill-in-the-blank type stuff. Okay? In fact, I think there is just one proof that you have to actually, like, start to finish, do it. And on that one, ignore what the directions say. If you want to write it as a 2-column proof, you write it as a 2-column proof. If you want to write it as a flow proof, you write it as a flow proof. Okay? If anywhere in the directions it says, write a paragraph proof, don't do that. I'm not going to make you guys do that. Okay? You can guess what that might look like, though, and they're not fun. When I was in college, I took a geometry class. Every homework assignment, I kid you not, if you complain, I don't care. My homework assignments, when I did geometry, this is college, but every single homework assignment was 10 proofs, each of them a paragraph proof. And the paragraph proof for each problem took an entire page. Explain to me. Okay? And worse. Okay, I'm done. I'll get off my soapbox.